Hi there. Today we're going to be learning about polynomial division. There are two types of polynomial division. There is what we call long division, and there is synthetic division. And yes, that was my little bambino you heard there. It's okay, we'll just continue here. So before we get into the actual process of dividing polynomials, I want to talk a little bit about how division and factors are related to each other. So I have a question for you. Is 3 a factor of 17? Most of you, hopefully, will say no. That's a pretty obvious question. But I want to show how division can help us see that it's not a factor. We all know that 3 times nothing is 17. That's primarily why it's not a factor. So we can use division. And I'm going to take 17 and divide it by 3. And this is what you guys have been known to call long division. And basically, we know that 3 will go into 17 5 times evenly. And then 3 times 5 is 15. And then we subtract. So 17 minus 15 is 2. And 2 is what we call the remainder. And because there is a remainder, that means that there is no, that 3 is not a factor because there's a remainder. The remainder is huge. So I want to cover the different parts of this long division. This is a very short long division, but that's the remainder. We have what we call the divisor, the number you divide by. And we have what we call the answer, so to speak. This is the quotient. That's what is referred to as the quotient. And of course, the number inside the little house, we call that the dividend. Most of the time when you divide, you don't think about all these things, but there we go. So we know that 3 is not a factor of 17. When it says to explain, we can simply explain it because there's a remainder. When you divide by 3, there's a remainder. So it's not a factor. I also want to go over a couple of different ways that we can represent division. There's what we call the improper fraction. You guys know what that means? Something like 17 over 3, we call that improper because the top is bigger than the bottom. And when you have an improper fraction, we write it as a mixed number. So you recall that it goes in 5 times evenly with a remainder of 2 over 3. That's a mixed number, 5 and 2/3. Literally means 5 and 2/3. 5 plus 2/3 is in fact 17/3. And then we have what we call the division algorithm. And the division algorithm says that the number 17, which if you remember was the dividend, is equivalent to the divisor, which was 3, times the quotient, which was 5, plus the remainder. And this is in fact true. Let me move this guy over here for a second. So I'll put this here. The dividend, the 17, is equivalent to the divisor, what you divided by, times the quotient, how many times it went in evenly, plus the remainder. This is important because all of these things that we see here in a really basic example, we're going to see in the polynomial examples. So my next question for you, is 3 a factor of 15? This gets a lot easier to explain because when you do the division, we all know that 3 goes into 15 5 times. 5 times 3 is 15. When you do the subtraction, you get a 0 remainder. So this idea of having a 0 remainder is really important. You can even use the division algorithm to say that 15 is equal to 3 times 5 plus a 0 remainder. So we can see how the 0 remainder is a huge part of this division stuff. So now we're going to graduate to some polynomial division. I want you to keep in mind, if you need to go back to the previous video, that's totally fine. Or if you want to rewind to the beginning of the video, I want to remind you how division works. Okay? I'm going to very quickly put over here off to the side. We had 17 divided by a 3. And we know that 3 goes in 17 5 times evenly. And then 5 times 3 was 15. And then you subtracted to get 2. That's very important because now we're going to take our dividend, which is x squared plus 3x minus 12, and we're going to divide by x minus 3. Okay? And like our long division from earlier, we are going to do a couple of things. First of all, we need to know how many times this thing going evenly, like the 5 up there. Well, how you do that is you take the leading term, which is x squared, and divide it by the first part of the divisor, which is x. And when you do that, you get x, right? Because this x will cancel with one of the ones on top, and it'll leave you with just one x. So that's how you know what to put up here. Okay? That's kind of the part where the 5 comes from in this example. Now the next step, how do we get the 15 from this example? We multiplied these two. And that's the same thing that's going to happen here. We're going to take x times x, and it's going to be x squared. We're going to take x times negative 3, and it's going to give us negative 3x. Alrighty? So that's that step. Then you will recall again from this example that you then subtract the 15. Okay, so we are going to then subtract, alrighty, this expression here. So x squared minus x squared is 0, so they cancel. And then 3x minus a negative 3x is actually 3x plus 3x, which is now 6x. And then you bring down the minus 12. And then we do it all over again. So now my leading coefficient is 6x. So again, to determine what goes up here in the quotient, we take 6x and divide it by the x again. And the x's cancel and you get 6. So it's a positive 6. So that means I put a plus 6 up here. And then we do the same thing all over again. We're going to take 6 times x is 6x. 6 times negative 3 is negative 18. And of course, don't forget, we're going to subtract that expression. And 6x minus 6x cancels. Negative 12 minus a negative 18 is negative 12 plus 18, which is in fact 6. Correct? Negative 12 plus 18 is 6. So now we're done. At this point, we no longer have an improper fraction. See, if you, I'm going to erase this here. We don't need this right now. But what we had was an improper fraction. See, we had x squared plus 3x minus 12 over x minus 3. And this example here is 17 over 3. And we consider this improper because 17 is bigger than 3. When we write this problem like this, like a fraction, we consider this improper because the top is an x squared and the bottom is an x to the 1 power. So the top is bigger than the bottom. It's called improper. Well, now I have a 6. Okay? My answer is going to be x plus 6. We're going to write it as a mixed number. So this is my quotient. And then we're going to add the remainder divided by the divisor. This is no different than writing 17/3 as a mixed number, which would be 5, which is the quotient, and then plus the remainder over the divisor, 5 2/3. This is quotient plus the remainder over the divisor. But this fraction, since you have x to the 0 on top, the 0 on top is not bigger than the 1 on the bottom. So this is not considered improper, it's considered proper. Just like the 2/3 is considered proper because the top is smaller than the bottom. So that, in a nutshell, is how you do long division. So now I want you to do this example problem by yourself in your notes. It's one that you're going to be comparing with your peers next class period. All right, so now that you've done that, we're going to go, sorry my screens are going crazy here. We're going to go to this guy, example 2. It says, determine whether x plus 4 is a factor of each polynomial. So this goes back to the idea of the factors question that I asked you earlier. How did we know that 5 is a factor of 15 or that 3 is a factor of 15? And how did we know that 3 wasn't a factor of 17? Well, it all depended on the remainder. If your remainder is 0, like it was in the case of 3 and 15, then it's yes, it is a factor. If your remainder is not 0, then it's not a factor. So what we're going to do is to determine whether x plus 4 is a factor, we're going to do division. So I'm going to take x squared plus 6x plus 8 and divide it by x plus 4 to see if I get a remainder or not. So as before, we determine what goes up here in the quotient by taking x squared divided by x, which gives us x. So x goes there, and now I'm going to multiply x times x squared, x times 4, 4x, and then we're going to subtract x squared minus x squared is 0, 6x minus 4x is 2x, and then you bring down the 8, and we do it again. We take 2x divided by x, and you get 2. So now I'm going to put a plus 2 up here. 2 times x is 2x, 2 times 4 is 8, and then we subtract, and 2x minus 2x is 0, and 8 minus 8 is 0. Beautiful. So we got a 0 remainder. Because we got a 0 remainder, the answer for part A is yes. X plus 4 is a factor of this polynomial because when we divided, we got a 0 remainder. Now let's try part B. And we'll move this guy over here to get out of my way. And again, we're going to use division. We're going to take x cubed plus 3x squared minus 6x minus 7, and we're going to divide by x plus 4. And you're going to have to pardon the closeness there. But to determine what goes in the quotient, we need to take x to the third and divide it by x, which gives us, in this case, x squared. So x squared is going to go up here. I'm sorry that it's kind of clouding the space there. Perhaps we can just use our eraser and we can erase this black part. Oops, that didn't work. Let's get our eraser and get rid of this guy so you can actually see better what's happening there. So x squared. So now we're going to multiply x squared times x is x cubed. X squared times 4 is 4x squared. And don't forget, we have to subtract. So x cubed minus x cubed cancels. 3x squared minus 4x squared is negative x squared. And then you bring down the negative 6x, bring down the negative 7. And now we take our negative x squared, divide by x, and now I'm going to get negative x. And so negative x goes up here. Negative x times x is negative x squared. Negative x times 4 is negative 4x. Subtract. A negative x squared and 2 negatives makes a positive x squared. They cancel. A negative 6x and 2 negatives here make a positive 4x. So negative 6x plus 4x is negative 2x. And of course, you bring down your negative 7, and we do it again. Negative 2x divided by x gives you negative 2. So then over here, we're going to get negative 2. Negative 2 times x, negative 2x. Negative 2 times 4, negative 8. When we subtract, these two negatives make a positive. Negative 2x, positive 2x cancels. Negative 7, 2 negatives make a positive 8. Negative 7 and positive 8 is 1. Now, I don't know about you, but 1 is not 0. So in this case, there was a remainder. The remainder was not 0. The remainder is 1. Therefore, the answer to this question is no. X plus 4 is not a factor of this polynomial because we did not get a 0 remainder. We got a 1 remainder. So now I'd like for you to try these two examples here. Again, it says determine whether each divisor is a factor of each dividend. So in this case, x minus 8. In this case, x plus 2. Make sure that you answer yes or no at the end, depending on whether or not you got a remainder. Okay, so next, we're going to go here. This is not something I need to do, but I want to do, because oftentimes students get confused when some of the terms are missing. So far, all the examples that we've done, there's always been an x squared, an x, and a constant term. In this case, you're missing some terms, and that can create some confusion. So I'm just asking you to divide here, so I'm going to take x squared plus 3, and we're going to divide that by x minus 1. Okay, so the first thing we want to do is figure out what the quotient is going to be. So we take x squared and divide it by x, and we get x. So here we're going to have x, and when you do that, you're going to get x times x is x squared, x times negative 1 is negative x, and you're still going to subtract, but you have to be really careful that you're not combining the wrong terms. In other words, x squared minus x squared cancels, but you can't combine 3 with x because one's constant and one's linear. So all you can really do is negative times negative is a positive x and positive 3. It just kind of comes down. So you don't combine them into 3x, they're not 2x, they're not, it's just x plus 3. And then you continue all over again, like we have in the past. So you take x divided by x, which is 1. So then you're going to put plus 1 over here. And 1 times x is x, and 1 times negative 1 is negative 1. And then you do your subtraction. X minus x cancels. 3 minus negative is 3 plus 1. So that's 4. So you get a remainder of 4. If you want to write the answer out, the answer would be x plus 1. And then you add your remainder, which is 4, over the divisor x minus 1. This would be your answer as a mixed number. Okay? And that's how you do that. All right, we did that already. Do that already. Okay. The next thing I want to teach you how to do is synthetic division. Synthetic division is basically a way for us to totally simplify the division that we just did. Long division can get kind of complicated. But synthetic division is really easy. But I do want to make one disclaimer. Here it is up here. That synthetic division only works if you're dividing by a linear divisor. This is x to the 1 power. If you were dividing by x squared, or x to the 5th, or x to something other than x to the 1, then you can't use synthetic division. It only works when you're using a linear divisor. So how does that work? Okay, I'm going to do this example for you. You can rewind as much as you want if you need to. You make a funny looking L, and with synthetic division, you don't have to use all of the variables. You just need the coefficients of all of the terms. So 3, 2, 1, none. 3, third power, second power, first power, no power. If any of these terms are missing, then you need to put a 0 in its place. But in this case, all the terms are there, so I'm going to just put the coefficients. 3, negative 4, 2, and negative 1. Those are the coefficients of the 4 terms. And then the other tricky thing is your divisor. Because this is x plus 1, you actually want to put the solution to that. In other words, if you took x plus 1 and made it equal 0, it'd be x equals negative 1. And negative 1 is what you're going to put out here in your synthetic division. And then there's a pattern. And if you just watch me do it, and if you want to rewind it, you can. I don't think you need to see it more than a couple times, but you can rewind it. You always bring down the first number. Just bring it down. And then you're going to multiply 3 times negative 1. And that goes here, negative 3. And then you add these together. So negative 4, negative 3, negative 7. And then you do it again. Multiply negative 7 times negative 1, it's positive 7. Add them together, you get 9. 9 times negative 1 is negative 9. Add them together, and you get negative 10. This, that I just squared off, is your remainder. With synthetic division, the last number in your bottom row is always the remainder. And then these numbers here are the coefficients of your quotient. And they're always 1 degree less than what you started with. In other words, this is a cubic, so these numbers will be a quadratic because it's 1 degree less. Had this been a 4th degree, then these would have been a 3rd degree. Had this been a 5th degree, then this would have been a 4th degree. But because this is a 3rd degree, this is going to be a 2nd degree. So my answer would be 3x squared minus 7x plus 9. And then your remainder is plus, or in this case it's a minus 10, it's a negative 10. So my remainder is actually going to be not a plus, but a minus 10 over the divisor. What did I divide by? Negative 1. but you want to go back to this, and you divide it by x plus 1. And that is how you do synthetic division. So now we're going to have you do the same thing here with this example. In your notes, please. Okay. So now we have our last little thing to teach you here, and it is the remainder theorem. And the remainder theorem gets really weird when you read it in the book, because math books have a funny way of making things complicated. So I am going to simplify it for you. This is what the remainder theorem says, that when you divide a polynomial, we're going to call it p of x, by some linear factor like x minus a, then the remainder of that division, so when you divide, you get a remainder. That remainder is the exact same thing as evaluating p of a. And if that still doesn't make sense to you, I will explain it to you. We all know what p of negative 4 means, because we've already done function notation before. P of negative 4 literally means to take negative 4 and plug it into the polynomial. So let's do that first, over here. What would p of negative 4 be? It would be negative 4 to the 4th power minus 5 times negative 4 squared plus 4 times negative 4 plus 12. And with my trusty little calculator over here, we know that negative 4 to the 4th power is 256. And then we have negative 4 squared, which is we know is positive 16. And 16 times negative 5 is negative 80. So there's negative 80. And then 4 times negative 4 is negative 16. And then plus 12. So 256 minus 80 minus 16 plus 12 is actually 172. So when I evaluate the function, I get 172. Well, wouldn't you know it, with synthetic division, I get a similar answer. So A, you get to see me do synthetic division again, and B, you get to see how this works. Okay? So we're going to take our negative 4, which is the x value, and we're going to put that out here, negative 4. And then we're going to have all of these terms. Now notice that the cubic term is missing. There's a 4th, there's no cubic, there's a squared, a linear, and a constant. When that happens, I'm going to put a 0 in its place. So here's a 1 for x to the 4th, 1x to the 4th. There's 0x cubed, there's negative 5x squared, there's 4x, and then there's 12. Okay? So according to synthetic division, we always bring down the first number, which is a 1, and then multiply. 1 times negative 4, negative 4. Add these together, 0 and negative 4 is negative 4. Negative 4 times negative 4 is positive 16. 16 minus 5 is 11. 11 times negative 4 is negative 44. Negative 44 plus 4 is negative 40. Negative 40 times negative 4 is positive 160. And 160 plus 12 is OMG 172. This is the remainder. So did you notice that that's 172 and this is 172? That wasn't a coincidence. That's the theorem. That when you divide a polynomial by a factor, by x plus 4 in this case, okay, then the remainder, right here, is the same as evaluating this guy, okay? So here's your last example for your notes. I want you to use synthetic division to find p of negative 1. I don't want you to plug negative 1 into the function. I want you to do it by using synthetic division, okay? So that is a wrap for this lesson. Awkward pause now as my cameraman comes to the rescue.